Hello everyone, this is tutorial 6 of Math 2000. Today I have 3 questions prepared for you, so let's jump right in. Question 1. Find the absolute maximum and the absolute minimum of this function f, which equals to x squared plus yz, on the closed unit ball B. So to do that, I'll break up the work into 2 cases. Case 1 will be what happens when we're inside the ball. So x squared plus y squared plus z squared is strictly less than 1. So here, because it's an open set, we will find the gradient and set the gradient at 0 to find the critical points. So the gradient of f is equal to the partial with respect to x, partial with respect to y, partial with respect to z. We set that equal to 0. And then we solve for it. And we see that this is the only critical point. And that's it for case 1, really. For case 2, we will then look at what happens on the surface of the ball. So that's x squared plus y squared plus z squared equals 1. And to do that, we will use Lagrange multipliers. So let's do that. So now we have g x y z equals to x squared plus y squared plus z squared minus 1. By Lagrange, we have that the gradient of f is equal to lambda times the gradient of g for some scalar lambda. So what that means is we have the following. So this is the partial for with respects to x. This was a partial with respects to y, partial with respects to z for f. And then for g, the partial with respects to x is this, partial with respects to y is this, and partial with respects to z is this. And obviously I have to scale by lambda too, because of that part right there. And then I'll have a fourth constraint I want to satisfy, which is x squared plus y squared plus z squared equals to 1, because I'm on the surface of the ball. So by Lagrange, I now have these 4 constraints. Because I have these 4 constraints, I now look at the top equation. The top equation says 2x equals to lambda times 2x. So quite obviously, or 2 lambda times x rather, tells me, or tells us, lambda is either equal to 1 or x is equal to 0. That's pretty straightforward. So now we look at the case when lambda is equal to 1. So case 2a, lambda is equal to 1. Now I substitute 1 into the 3 of the 4 constraints you see above. So what does that give me? It gives me this. 2x equals to 2x. Z is equal to 2y. Y is equal to 2z. And x squared plus y squared plus z squared is equal to 1. Okay. Then we take this equation and this equation, and we look at what happens when we substitute them into each other. So then, z is equal to 2y, and y is just 2z. And that tells me it's equal to 4z. So then the only possible solution is z is equal to 0. And if z is equal to 0, then y is equal to 2z, which is 2 times 0, which again is 0. So then if we substitute z equals to 0 and y is equal to 0 into the top equation, or the main constraint, which is x squared plus y squared plus z squared equals 1, then we have x squared plus 0 squared plus 0 squared equals 1, and that tells me x is equal to plus or minus 1. So here, for case 2a, we have x is plus minus 1, y is 0, and z is 0. And that's it for case 2a. Case 2b is when x is equal to 0. So if x is equal to 0, let's look back up here again. We have 4 constraints, and x is 0, so the first equation is nothing. The second and third equations stay the same, and the fourth equation simplifies to y squared plus z squared equals 1. So again, we have 0 equals 0. We will have z equals to 2 lambda y. Y is equal to 2 lambda z. And we will have x squared plus y squared plus z squared. So this is equal to 1. Okay. And again, we will look at the second and third equations. So we'll look at this equation and we'll look at this equation and combine them together. So then z equals to 2 lambda, y is 2 lambda z. I can write that better. That's equal to 4 lambda squared z. So then, if we move everything to one side, we have this. Okay, so we might consider if z is equal to 0. If z is equal to 0, because either this is 0 or this is 0. So if we consider what happens if z is 0, then y is equal to 2 lambda z, which is 0. But then we would have y squared plus z squared is equal to 0 squared plus 0 squared, which is 0. That's obviously not equal to 1. So it's a contradiction. So this is, in other words, to say z is never equal to 0. So i.e. z cannot be 0. And if z is not equal to 0, then this guy must be 0. Therefore, 4 lambda squared minus 1 is 0. And if that's equal to 0, then I could simplify it to saying, what? I could say lambda is equal to 1 over 4 square root. Well, that's just plus minus 1 over 2. So now I take back z as lambda as plus minus 1/2. I could substitute it back into this equation and this equation. So then z is equal to 2 lambda times y, but lambda is plus minus 1/2, so that's just plus minus y. And then we have y squared plus z squared is 1. So y squared plus z squared, well, y squared will stay the same. Z is just plus minus y, so square is just another y squared, and that's 1. So then y squared is 1/2. And if y squared is 1/2, then y is equal to 1 over root 2, plus minus. And likewise, z was just plus minus y, right? So we would have that. So overall, we have x is 0. So we recall x is 0. And overall, we will have these possible cases. So now we finished case 1, case 2a, and case 2b. Now let's see what happens when we apply f to those points. So now let's check what happens when we apply f. So case 1, we only have 0, 0, 0. So let's apply f. We apply f to this, that's 0 squared plus 0 times 0, which is just 0. Then we apply f, so that's 1 squared, or plus minus 1, but you square it, which is just 1, plus 0 times 0, which is 1. And then this, 0 squared plus 1 over root 2 times 1 over root 2. That's half. And let's continue with this. So same idea, you're just going to get minus half. Here you're going to get minus half as well. And here you're going to get positive half. So by our analysis of case 1, case 2a, and case 2b, we see that 1 is the absolute maximum. We see minus 1/2 is the absolute minimum, and it occurs twice. So let's finish the question. So conclusion. The absolute max of f on the closed uniball S is positive 1, and it occurs at, when does it occur? It occurs at plus minus 100. So it occurs twice. Once at positive 100 and once at negative 1 and then 0, 0. The absolute min of f on S is negative half, and it occurs at 0, 1 over root 2, negative 1 over root 2, and 0, negative 1 over root 2, 1 over root 2. And that's it for question 1.